mentioned in statistical inference, our aim is to estimate population parameters using observed sample data. By producing a confidence interval, we use a sample data in hand and do some calculations to give an estimated range of values which is likely to include an unknown population parameter. When we calculate a 95% confidence interval for a population parameter, for example mu, we produce a range that if we take 100 times a sample of size n from that population, 95 times of that will include the population mean. In other words, we are 95% confident that this range includes the population parameter. And that is in your reading 9.1.1. Now in this slide, I have shown you some hypothesis testing scenarios. And so when you want to decide what kind of test you need to do, these are, we say that what kind of test we want to do. If you're comparing means, then which kind of means? Is it one sample or is it two sample? Is sigma known or is it unknown? If it's known, you do a z-test. If it's not known, you do a one sample t-test. If you have got two sample, how the data is structured? Do you have two independent samples? You do two independent samples t-test. Or do you have a measurement before and after something? Then you have dependent samples, longitudinal data, and you use paired samples t-test. But if your question was about relationship between variables, then you have a look and say, okay, what kind of variable are they? Are they both nominal? You do a chi-square test of independence. Or are they both interval or ratio? Then you do correlation or regression. Regression would be the final topic in our course for this subject. Now, in lab 9, in this lab you first enter an array of numbers for variable isotopic, then another array of numbers for variable test weighting. The question is whether there is a significant difference between these weight measurements. Then you have to conduct a paired t-test and discuss the results. Now in here we just say that, okay, you define the parameter of interest, so you say let mu d be the difference scores between isotopic and test weightings. Here we have conducted a paired t-test, but we have not included all the data. The null hypothesis mu d means that the mean of the difference scores is equal to 0. Here you have got the alternative hypothesis. It's a non-directionalized two-tail test because we use not equal to. Then T with thin degrees of freedom. Here what you do, you have your data and you do the T dot test, and then the whole result is here, and you see the statistic is 2.7416, degrees of freedom is 13. So p-value is 0.01681. So because 0.01 is less than 5%, we have got enough evidence to reject the null hypothesis. Now in question 2, you have got again paired t-test, and let mu d be the difference scores between isotopic and test weightings. And here we have conducted a paired t-test, but we and then you have got the test statistic as 1.703 because the number of data is smaller. And you will see that the p-value is large and you haven't got enough evidence to reject the null hypothesis. Thank you.